Good morning, chemistry. I'm going to make this quick little video to respond to some of the questions you guys had about the gas laws, the gas laws lecture that I put on before. So if you'll bear with me a second, I'm going to pull up, first of all, the questions that you asked, and then I'll also pull the responses that you guys wrote for me. All right. Firstly, let's look at your questions that you asked. Okay. I can't get this thing. There you go. All right. So the first one here that says which number divide from the other number. I'm not exactly sure what you mean by that. But what I can tell you is that you really are just going to try and isolate for one of the variables. So when you divide, it's usually because, if you're solving for n, you will divide both sides by r times t. Or if you're solving for the v, then you'll divide both sides by p. So you're really just going to try and cancel out all of the numbers on one side of the equal sign or the other. So it's like regular algebra. Okay, there's really nothing special about it. Here's a pretty good one. When would you use the combined gas law over any of the others? Combined gas law is really the one that I use anyway. Like, if I'm not using Pervnert, I am only going to use the combined gas law. And the only time you'd use the combined gas law, but not Pervnert, is when you don't have to worry about numbers of moles. You don't have to worry about a chemical reaction occurring, or Dalton's law of partial pressures issue, where you're given just straight up pressure, volume, or temperature, and there's no mentions of mass, no mentions of moles, molecules, that kind of thing. If you have numbers of molecules, or if you have numbers of grams, then you're probably going to have to convert that to moles, and then you have the n value for your Pervnert. Let's see. End of question 2 got me a little confused. I don't remember what question 2 is. Oh, probably from the video. Okay, I can't remember exactly what was on the video, so I'm sorry about that. I'm not going to be able to do you a lot of good right there. Let's see. Let's see. I don't understand the units for R. Okay, well that's a question I like to answer. So you don't understand the units for R. That is actually pretty normal, because they're the weirdest units you've ever come across so far, probably in all of your schooling. So if you'll just give me a moment, I'll pull up the thing that I just pulled up the Chem Bible, so you guys have something familiar to look at. Okay, well, sorry, it's on its side, and now it's blinking at me, and I don't know why. Okay, so you can see right here the R values, and we have several different oh, that's annoying. I don't know if you guys can see this blinking, but it's killing me. You see we have several different values for R, and the number that you put in the R spot is going to be entirely dependent on basically which pressure unit you're going to be using. If you're given kilopascals, then you would use the 8.314 or 8.314 liter kilopascals per mole Kelvin. If you're given atmospheres, you'd go 0.0821. If you're going millimeters of mercury, or Torricelli units, or I think bars. have to look somewhere on here. It has all the different R value, or all the different things that R stand for. You would use 62.4 for that. So the reason why different numbers are here only because the unit of pressure that you're supposed to be using is going to be different. So if you aren't given a specific pressure, it just says what would the pressure be, then you have the option at that point to use whichever one you want. You can use any of those R values. And then just make sure that when you solve for P, the unit that you put on P is labeled with the pressure unit that is inside that particular R constant. All right. But that's kind of the nature of R and R constants. Let's see. Let's pull up another question. Don't know why that one kept blinking at me. All right. So the next question, ideal gas law. Ideal gases are different from, real gases, I guess is the term that they use. A real gas, is going to be, a little bit more varied because of just, wind. I noticed in my own home that if I have a window open, the gases inside my home are going to behave differently from the gases when I don't have a window open. And so what we have is an ideal. We have something that's set up that we can compare all behaviors of gases to, and that's the reason why we have an ideal gas law. The ideal gas law itself is the only one that takes into account the numbers of moles. So if you want to know stuff about gas at that instant, the way that it is, then you would use the ideal gas law, because sometimes you have more molecules and sometimes less. If I'm up in the mountain, I'm going to have fewer molecules to work with than if I'm down at sea level. And the combined gas law requires like a before and an after. So it's telling a story of gas when it was going through some kind of a process. Pervnert tells us about the gas right now. So that's kind of a difference between those two. Down here it says I don't understand the units for R. Okay, we just covered that. And it looks like, oh, missed some at the beginning. Let's see. How would you know what gas law unit to use? Where did you get 62.4 from in the beginning? All right, so that 62.4 is the number that goes with that particular R value if you're dealing with millimeters of mercury or Torricelli units or something like that. All right. So I hope that was helpful for you guys. Please come talk to me in the mornings if you have any other questions. Actually, even if you just do your assignment in the morning when I'm on between 8 and 10, and then you can pop on and ask me questions as necessary. All right. Thank you.